Hello everyone. Today we are going to discuss the new term in the periodic trends that is called as electronegativity. Okay. In last lecture we have studied about the periodic properties such as ionic radii, atomic radii, ionization potential, electron gain enthalpy, etc. Today we are going to study the most important property that is known as the electronegativity. In this lecture we are going to see the following points. First is definition. Second is electronegativity values for S block. Third criteria is about factors affecting on electronegativity. And fourth factor is about, that is the periodic trends. Now one by one we will discuss these factors. So let us study about the definition one. The definition of electronegativity as follows. It is the power or ability of an atom in an isolated gaseous state to attract the shared pair of electrons towards itself and becomes a negatively charged species is known as electronegativity. Okay, what is the definition here? The power or ability of an atom. What is the power here? That is, in an isolated gaseous state to attract the shared pair of electrons towards itself and becomes it is a negatively charged species. This is the definition of the electronegativity. The scientist Linus Pauling, according to several experimental techniques, developed the two scales for electronegativities. For this, according to Linus Pauling, it is developed two scales for electronegativity, as first is more electronegative and second is less electronegative. What are the two scales? First is for more electronegative for species containing, for example, the fluorine, and less electronegative is of Ca. Okay. What are the electronegativity values? He assigned the fluorine as the value is equal to 7 and for Kcm is equal to 0.4. Okay. Thus, according to Linus Pauling, he assigned more electronegative and less electronegative elements having the electronegative values between the range that is equal to 0.4 and here 7. Now we are going to discuss the factors affecting on the electronegativity. There are some factors which affect the electronegativity. They are as follows. First is about atomic size. Second is about nuclear charge. Third factor is screening or shielding effect. Fourth factor is about hybridization. Fifth factor is about bond order. Okay, now one by one we will discuss it as follows. First is atomic size. Now, as far as atomic size is considered, here the electronegativity values are increases with decrease in atomic size. Okay, what I am saying to you, that is electronegativity values are increases with decrease in atomic size, because here electronegativity values, as far as consider here, the atomic size is goes on decreasing from left to right, that is along a period. That is, in another words, we can easily say that is electronegativity is inversely proportional to atomic size. Okay, now second factor, that is nuclear charge. As far as nuclear charge is considered, when the electrons are added to respective outermost shell, at that time what happens? The attraction between positively charged nucleus and outermost valence shell electrons is decreases. Thereby, there is, with increasing number of electrons, nuclear charge is also increases. And as nuclear charge is increases, thereby increase in values of electronegativity. Increase in values of electronegativity. For example, here due to the electron addition, that is, in case of the halogens, we have considered the fluorine having the electronegativity that is equal to 4 and that of iodine is equal to 4.5. Okay, that is due to the size of this fluorine goes on decreasing from here. Therefore, here as electronegativity value is equal to 4 and that of iodine is equal to 4.5. That is, in another words, we can say that electronegativity is directly proportional to its nuclear charge. Okay. Now, what is the next factor? That is going on this screening or shielding effect. Third factor, screening or shielding effect. In last lectures, we have explained about the shielding effect. Again, I am going to remind you what is screening or shielding effect. When the electrons are added in the outermost shell, at that time the nuclear charge on the increasing number of electrons goes on decreasing. Okay, as the nuclear charge acts on the number of electrons, therefore as electrons are increases, therefore nuclear charge is also increases. But the attraction between the inner positively charged nucleus and the outermost valence electrons is going on decreases. So in order to protect this nucleus from the outermost shell of an electrons is increased, that means there the shielding effects is goes on decreases. Okay, that is, in another words, we can say that with electronegativity values as increases, there is decrease in screening or shielding effect. Screening or shielding effect. Okay, now the next factor is going on, that is known as this hybridization. Fourth factor, hybridization. In my next video, we are going to see the next topic, that is known as the valence bond theory. In this valence bond theory, we are going to discuss what is meant by a hybridization. Again, I am going to discuss only definition for hybridization, that is the mixing and recasting of atomic orbitals of nearly same or equivalent energy to form a new set of hybrid orbitals of equivalent energy and same shape. The phenomenon is known as the hybridization. As in the hybridization, we are consulting with the percentage of S character. S character. According to the type of the hybrid orbitals can take part in the hybridization. Here, increase in percentage of S character going to increase in the values of electronegativity. As the electrons or type of orbitals overlaps are very close to the nucleus. Okay, that is, as the percentage of S character is increases, there is increase in the values of the electronegativity. Now, next point, that is the bond order. Already you know how to calculate the bond order, that is number of bonds present between the two atoms in a molecule, that is called as a bond order. Again, we have defined it as bond order is equal to, that is equal to BO is equal to 1/2 into number of bonding electrons, bonding minus number of anti-bonding electrons. Okay, this is called as a bond order. But in case of electronegativity, what happens? For example, the bond order in C2H2, that is equal to C triple bond CH, okay, bond 3H. Here bond order is equal to 3, okay, and bond order in ethylene, that is CH2 double bond CH2, the BO bond order is equal to 2. Okay, now as the bond order is increases, there is increase in the character of a electronegativity. That is, with increase in bond order, there is increase in electronegativity character. Okay, now I am going to give you some electronegativity values in a S block elements. See here, and the values are going to discuss with you, that are as follows. Here, first is about lithium, beryllium, then boron, carbon, nitrogen, oxygen, fluorine, then Cl, Br, and here I. Okay, now I is equal to what? That is equal to 1.1, 1.0, 1.5, 2.0, 2.5, here nitrogen 3, Okay, 3.5. Fluorine is equal to 4. Already we are discussing it with you. That is equal to Cl is equal to 3. Br is equal to 2.8 and I is equal to 2.5. Thus, here we are discussing it with the electronegativity values for the elements in the which block? That is some of the elements in the S block, some of the elements in the P block. So these are contributing the S block: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, Cl, Br contributes to a P block. As the electronegativity values are increased from lithium to beryllium, okay, that is from beryllium to boron, that is we can easily say that the electronegativity values are increases from left to right, that is along a period, and from left to right, that is along a period, that is equal to 2.5 to 3. That is carbon having the atomic number is equal to 6, nitrogen having the atomic number is equal to 7, O8, 9, 17 and so on. Okay, now we are going to discuss the trends in the periodic tables. Trends in periodic table. Okay, in these trends we are going to discuss the 2 points such as along a group and along a period. In this along a group, the electronegativity values goes on decreasing. Okay, why? Because there is increasing size of the atom or species or element. Here, what happens along a period? Here, electronegativity values are increasing along a period. Why? Due to the decrease in size of an element. Okay, what I am saying to you, that is in the trends, as far as these trends are considered, along a group, that is electronegativity values goes on decreasing as there is increase in size of the elements, and along a period this, that is electronegativity values are increasing along a period. Why? Due to the decrease in the size of the elements. Okay, now as far as electronegativity considered, which elements are called as more electronegative elements? That is on between O, N and S. Oxygen is more electronegative than nitrogen, which is more electronegative in sulfur. Okay, this kind of character of increasing electronegativity you can keep on this mind, which will be useful for your identifying the electronegativity and the bonding pair of electrons which are attracted towards the species and becomes to attract the electrons or pull out the bond between them and so on. Thus, we have concluded the term electronegativity, its definitions, factors affecting and the trends. I hope that all of you like my video, and if like, please share and subscribe the video. Thank you.